Welcome back. This is Mr. Erlin. In our constructions for the triangle unit, we have some foundational steps that we need to learn how to do, or some tools that will help us in doing our constructions of all the triangle centers. We're going to need to be able to construct both by hand and using technologies such as GeoGebra or Geometer Sketchpad. We should be able to construct a median, an angle bisector, perpendicular bisector, and an altitude. All these are skills that you've learned previously, so really this is just review. But let's make sure we're all comfortable. In order to construct a median, well, what is a median? A median connects a midpoint of a side to its opposite vertex. So, if we want to find the midpoint of this side, the best tool we have for that, using our compass, is to construct what we call a perpendicular bisector. To construct a perpendicular bisector, we simply set our compass to be more than halfway of the side length, make an arc, anchoring on the other end of our segment. We use the same measurement to make another arc. That will produce for us a football. And in this football, we can expect that it's going to produce, by connecting the endpoints, a perpendicular bisector. In this case, we don't actually need the whole bisector. All we need is, we don't need the whole perpendicular bisector. All we need is the bisector component. We need to know that these two segments are equally spaced, equal length, because that then produces what we call the midpoint. And if we take that midpoint and connect it to the opposite side, connect it to the opposite vertex up here, we produce a segment called a median, connecting the vertex to the opposite side's midpoint. Second one we'll use is an angle bisector. If I want to, for instance, bisect this angle, my step one is to set my compass in such a way that I can cross over both of the rays formed by this angle. As long as it crosses over, we're fine. It can be longer, it can be shorter. From each of these points of intersection, the ray of the angle with the arc I've just produced, I anchor my compass, and I'm going to set it to be more than halfway, just like we did with the midpoint or the perpendicular bisector. I do recommend that you choose one that will not be the same length as the distance to your vertex. I'll show you why in a moment. I'm going to choose mine to be larger, produce my arc, use that same length from this opposite side's point of intersection. And if I've done this correctly, what I should be able to produce here is something that connects this end of the football with this end of the football and goes through my vertex. That's the reason I chose my length here to be different, because this gives me 3 points in a row. And I know that 3 points are not always collinear. That takes something special. So if I've done this correctly and I see that all 3 points are in a row, that tells me that I've done it correctly. And for this, I only need to draw that much of it, demonstrating that these two angles formed by this angle bisector are in fact congruent, knowing that this is then called an angle bisector. The third one we'll work with is something called a perpendicular bisector. Well, this is really a combination, or it's actually the same skill as this first one we did, just taken one step further. So I'll begin by recognizing I'm going to try to do a perpendicular bisector for this segment. I start from this end and go more than halfway, make my arc, carry that same length to the other side, make a corresponding arc, I produce a football, I take the endpoints of this football and connect them. This time I'm actually looking for the whole segment. I'm looking for something that satisfies both the idea of being perpendicular and a bisector. Last one is the altitude. For the altitude, what we're looking for is a segment that is not only perpendicular to this side, but tells me exactly how high up this point is. If I were standing on a mountaintop, I'd want to hang a string or dangle a string that has a rock on it to find out exactly how tall I am. So what I need to produce is something that is perpendicular to this line, but through this point. You might remember we learned this skill as perpendicular to a line through a point off the line. We begin by establishing an arc. Now, I purposefully chose this arc to be super long. I could have made it short and it would have crossed over. But the reason I've done this is to demonstrate that if you need to, you can extend your base further out so that it meets with your arc, establishing arc. By doing that, I now have the opportunity to use this endpoint to go more than halfway. Let's get a little tight on my page. More than halfway on this side. Now, if I've done this correctly, what I should find is these 3 points of intersection, my original vertex, this point of intersection, and this point of intersection, should all be collinear. And I should be able to establish a line that comes from this straight up in such a way that it is both perpendicular to the base and through that point exactly. That's called an altitude. This has been try 50, the median, angle bisector, perpendicular bisector, and altitudes of a triangle, constructing them by hand.